Cool. So yeah, we'll kick off. I'm Niall, and I'm presenting with Lorna today. I'm a data engineer at Tails.com. We sell bespoke dog food to lots and lots of dogs across Europe now, and as a result, we accumulate a lot of data, and it's important that it's good data. So we employed Great Expectations back in May, and we've been kind of scaling it up since then, with more and more team members getting involved. So really, today I'm kind of talking about how we've scaled the use in the team, got a really good local development environment going, and how we're deploying Great Expectations. And also kind of once we had that, how did we decide what to test, what not to test, how we decided who should be alerted. And then Lorna's going to go for a bit of a deep dive into a particular example where Great Expectations have been really, really useful for us. So just to kick things off, because I know that it's really annoying when you start a talk and you don't really know how someone's deployed something. Here's a load of logos and arrows. We are using Airflow to schedule our Great Expectations tasks. And we're running it on Kubernetes so that we have that kind of isolated running environment, so we don't end up with a dependency nightmare in our Airflow instances. And we're using this little Great Expectations operator, which I made, which is just an overridden Kubernetes pod operator. And there's a little script that runs inside there, which executes the checkpoint, which you pass as an argument. So I'll go on to explain a little bit how we use checkpoints and what this particular one means, this PagerDuty hourly one, but this is how we're running. And then we deploy the data docs and validations on S3 so that they're then accessible for everyone as well. So if anyone has any questions on this, like, we can talk about it at the end or send me a message. There's probably a lot of detail here that I don't particularly want to go into right now. So yeah, just drop me a message or something. So in terms of making this as useful as possible for the team, it has to be really easy to contribute to and set up checks locally without worrying that you're going to damage anything in production. And people need to be able to kind of play. So the first thing we did was build an isolated development environment where you could deploy the docs on your own machine, look at what your expectation suite was doing, and we wrote some really thorough documentation. Depending on the platform that you're using, just installing Python is actually quite difficult. So it's really important that that's really easy to do, especially for a team who might not have used it before. So we then did a demo session once that was done to kind of share some of the example expectations that Great Expectations provides and what sort of uses there are. There are some really good blogs out there as well of how people are using Great Expectations. So if you're a new team to the tool, I'd really recommend starting there. And then with local setup and getting people started with their first expectations, just helping people to get them set up. It's quite scary at first when you're using a new tool. So once people have the confidence, things scale really, really well. So that's what we did to start with. And once everyone was comfortable, in fact, sorry, apologies. Let me quickly go through local development deployment. So we have two project files that we use. There's the Great Expectations YAML file that everyone's familiar with. This is basically where you configure all of your data docs, locations and validation store locations. So we have a production one, which points to S3 and triggers the Slack and PagerDuty alert actions, which obviously you don't want to trigger when you're just testing locally. And then we have a local one, which doesn't have any of that. And we really simply just swap them over in the Docker file. So there's the setup for a local development is minimal. All you do is install Great Expectations, you run init, and that's it. You're good to go. So it's really easy to use. So this kind of leads us on to how do we decide what we wanted to test? Once all of the team were able to add their validations and their expectations, where do you start? So there was probably a reason that you came to Great Expectations in the first place, and that there certainly was for us. So the main thing for us was that when people notice that there's something wrong with data, or there's data missing, or the latency is bad, and they're end users, that's really bad for trust, because people start wondering whether the data is safe all the time, and getting to a position where you're able to tell your end users that there's a problem before they notice it means that they're always confident to go to that data and trust it, because if there's something wrong with it, they know that you'll let them know. So that's where we started. So we've added Great Expectations latency checks to some of our key data pipelines. And then from there, we started to add them to all new pipelines that we built as a kind of part of the process. And it's also been really helpful for just giving us more visibility over some data pipelines that maybe a previous member of the team made who's since left, things like that, just to get a bit of visibility. And the profiler is really, really useful for that as well, just to give you a kind of sense of the shape of data and what expectations you might want to add. So once you set up your tests, we then had to kind of decide, what do we want to do as a result? And Sam wrote a really good blog on this a couple of weeks back, which I'd really recommend taking a read of. But the kind of key questions are, who needs to know when something is broken? When do they need to know? Is it something which can be solved during business hours, or is it something which needs to be solved at any point in the night because it's impacting an operational system? And what do they do as a result? Is there a procedure to follow when that particular check has failed? And is there anything that can be actioned automatically? This is more important for people who are using Great Expectations checks in line with pipelines, which we actually aren't currently, but it's something to consider doing. So we've approached this with a concept of kind of tiers at Tails, where we decided which checks were really important for operational use cases. So are there automated emails being sent off the back of this data that we definitely don't want to send out? Or is it more for just kind of reporting, like end of month stuff? If so, we can probably just respond in working hours during the day. So we use Slack alerts for the non-critical stuff, and we aim to respond to those within a working day. But importantly, we communicate it still to the end user straight away so that they know to expect that there is an issue with the data and that they shouldn't action it. And then for the more serious, really, really critical issues, we have PagerDuty, which sends an alert out in the middle of the night if need be, if there's an issue with the data, so that it can be repaired before there's damage to the actual core business operation. And the way we've done this is with checkpoints, which aren't super documented, but they are basically a grouping of expectation suites with the corresponding validation operator, which is very Great Expectations terminology heavy. So if you're not sure what they are, go and take a look. But it's basically a way of taking a group of expectation suites and matching them with an operator, which includes an alert. So we have a validation operator for Slack, and we have one for PagerDuty. And by grouping them together, it means that we just have 3 scheduled tasks that run in Airflow. We have one which just runs business hours and goes to Slack. We have one which runs daily and goes to Slack, and then one which is hourly and reports to PagerDuty. So whenever someone wants to add a new suite of expectations, all they have to do is add it to that checkpoint. That's all they have to do. So it's really easy to contribute to as well. So that's it for me. That was a bit of a quick tour. So yeah, over to Lorna. Do you want to share your screen, Lorna, or should I just click through for you?
I think you can click through. I don't know if, unless people can't see me because you're on the screen, maybe.
Oh, well, I'll tell you what, let me unshare and you go. Have you got it up?
I know, it's all right, people can see me, so that's okay, because I can look at you.
Cool.
Okay. Thanks, guys. Yeah, so I'm Lorna Brightmore. I'm the lead data scientist at Tails.com. Yeah, so I just want to give a little bit of a deep dive about how we're using Great Expectations, particularly around our lifetime value model at Tails. So as you can see here from this slide, the way that we think about lifetime value at Tails is, it's a measure of how much money we think each individual pet is going to bring into the business. So it's a pet level model. It's made up of 3 parts, with a retention piece answering the question of how long we think you're going to be a customer, a frequency model of how often you're likely to order within that time frame, and a gross profit model, which is essentially how much profit do we think we're going to make off each of your future orders that you're going to buy. You multiply all of those 3 things together, and that essentially gives you a read on your estimate of a lifetime value. So if you click on, please. Yeah, so the questions then come of, whilst each individual component is reasonably transparent. When all of these things are together, it feels a little bit black boxy. So maybe, like as an example here, we have our forecast lifetime value for pets that signed up in November is 10% higher than October. And then the question is why? Is it because we've done something good to like actively increase the value of those customers, which is nice, and that's what we hope we can do? Or is it something else? Is it because for some reason the pets that we brought through in November are different somehow? And then in that case, is the model generalizing well to this new data because it looks kind of different from what we're used to seeing? Or is it something worse, like the forecast is inaccurate for some reason? And if that's the case, where? Because there's, again, we've kind of got 3 submodels that are laddering up to this lifetime value. So how do we know where exactly these errors might be? And so what we're using Great Expectations for here is to try and kind of pick into the bottom 2 cases that I've highlighted here and try and signpost where we may be having data drift in our inputs, like our input data looks different somehow, or where there's potentially errors and bugs in the forecast not doing what we want it to be doing. And so if you click on, please, Niall, I've got a real life example here of tails and lifetime value before we actually had Great Expectations. So in 2019, we started selling a Christmas range for the first time. And at Tails, this was the first time that we had the concept of people adding one-off things to their subscriptions that they would not normally have on a monthly basis. And so our first version of this lifetime value model, the gross profit assumptions was very heavily weighted towards recent orders, because before we started selling the Christmas range, that was a really great prediction of what our future expectation of your gross profit is going to be. But of course, when we fundamentally changed the relationship between your gross profit of your orders and how that ladders up to your lifetime value, what that meant in the forecast is that we were forecasting really high LTV for people based on the fact that they bought something over Christmas, which is obviously not a realistic forecast and not real and not like, something that we should do. What actually happened in this case, we spotted this shortly after Christmas that this was happening. The commercial team spotted it, we rectified it, and now we have better assumptions around this model kind of treating this case. And this Christmas, we've gone way bigger on the Christmas range, so this is no longer an issue anymore. But the problem here is that, as Niall kind of alluded to, like, it's kind of erodes a little bit of trust because there was something wrong in the forecast and we didn't spot it in time, which was a bit annoying. And had we had a Great Expectation suite set up over the gross profit model so we could detect when the input data, the shape of the input data that we were looking at was different somehow, we probably could have spotted this before and it wouldn't have baked into the forecast and been pointed out in the way that it did. So that was a little bit of a miss for us, but this is the type of thing that we're really using the Great Expectations for. So if you click on, please, Niall. So here, just to kind of give a little bit of a run through of what this practically looks like on our lifetime value model. So the retention is the most complex piece of this, and it's made up of like different cohorts of like lookalike pets and survival regression on top of that. So we have expectations here on the number of distinct cohorts at play, and also some descriptive statistics on what that means for like a forecasted retention at like a 3-month point post sign up. For the frequency and the gross profit models, again, similarly, we've got quantiles, we've got expectations around the quantiles here of, what the 25th, 50th percentile, those kind of things look like on these distributions, again, to kind of detect the areas in which, where we may be seeing a different shape of the input data, which could be affecting the output. And then finally, we've got some descriptive statistics, again, on the output of the lifetime value, so we can, help flag where things may look different, and then which component of lifetime value we should dig into to try and understand a little bit more. So just for my final slide, so some kind of thoughts on the process of setting these up. And this is the first model that I've done really thorough, to be honest, as much thorough testing as we have right now, and certainly the first thing I've personally used Great Expectations for so far. So my kind of learnings on this is where it's been most useful is helping to kind of signpost places to look rather than fully diagnosing the issue. Because I think if we tried to set up expectations to alert us to everything, we would get a lot, and therefore we would get a lot of false positives, and we'd probably make the whole process a little bit counterproductive. But it has been really useful to kind of like alert to the sort of logical components of the lifetime value model and where things might look different. Also, extreme values should be expected. And like, because there will be some pets that have like weirdly high, low or high values for certain things, and that's okay, that's just life. And so what's been much more useful than the max, min, and like mean type values, which actually I think the profiles one fires up first, is changing to statistics which are not so sensitive to extreme values. So medians over means, and using quantiles over the max and minimum values, because that still gives you the right, it still tells us what we want to do and reduces the kind of false positives to do different things. Good expectations takes practice. I guess we've all know that. It's, you know, it's a little bit of an iterative process about what you know, it's not always obvious what you should be expecting from your data when you start this process. But actually kind of like going through and thinking about that is, I think, quite an instructive way of like really kind of understanding and sort of like lifting the lid on your model and going through the process about thinking what like thresholds you would expect at different points. I think it's just good practice, to be honest, and kind of like I think has helped sort of improve the model overall. And also the final one, which I don't know the answer to this, and if anyone here had a good way of approaching this, I would love to hear it. That what we like, I spoke a little bit about model drift and where it's bad, but also there's some amount of model drift that we would expect. Like we expect our LTV to increase over time and our gross profit and our retention figures to improve because we're actively working at Tails to make those things better. So how do you set expectations and like an upper threshold for where you want a medium lifetime value figure to go through, knowing that at some point in the future, that's probably going to be too low because your data has moved on. And so how do you set useful expectations that give you the right alerts that you want, but kind of maintain them over time? The best answer I've come up with is just, as you periodically retrain the model, as you should to do maintenance, like maintaining the expectations becomes part of that process. But yeah, I don't know if anyone had a better exam, you know, had that experience and like solved that in a different way, I would totally love to hear that. But yeah, that's all from me really. That's the run through of how, you know, Great Expectations has been really useful in helping give confidence to our lifetime value metric and that it's doing what we want it to be doing.
Great.
Wow, thank
Cool.
you so much, Niall and Lorna. Niall, we're sorry, do you want to wrap up a little more?
No, that's good. Unless anyone has any other questions for now or later, or just drop me a message on Slack. I'm on the Great Expectations chat, so that's all.
Yeah, same.
And we actually do have some time for questions now. We had a lot of people join in just the last few minutes during that talk. So welcome to everybody. Thank you so much for joining this second community show and tell. This is absolutely one of my very favorite things we get to do because I learn a lot and it's just a blast to see how people are really embracing, understanding, and pushing on Great Expectations. Lorna, a couple of the things you said were like textbook quotes for me. I have done a lot of work in data science over years, and you know, especially some of your comments you made about like the way that expectations helps to become a best practice in the workflow of informing yourself about your data and consequently how your model should be structured. I just love it. Let me open up for questions right now for Niall or Lorna before we move on.
I have a question. Is there a place where you store your stock photos for your dog that I could use?
I mean, we got a lot of dog photos. I realized like after joining Tails, my phone reel is basically just dogs and whiteboards. And that's like all I take photos of now.
I'm jealous.
I'm pretty
Like
lucky.
the easiest way to get hold of dog pictures is probably to sign up for the service, and we send you quite a lot of emails with content about how to set up and get yourself set up with the dog, and they're covered in dog pictures. So, you know, shameless plug.
Oh,
Are you only based in the US or in the UK? Do you do stuff in the US also?
We're currently in the UK and Europe, but not in the US at the moment.
Do they have Bark magazine in the UK? Do you guys know about Bark?
I have never heard of it, but I don't know
So,
about anyone else.
Oh, you need to look
Sounds
at
like
Dark
there's yeah, there's going to be some homework for everyone. I actually also had a question. I was really interested in your comment about the kinds of expectations you chose, specifically because of the reality that there are extreme values that you would expect in your data set.
Mhm.
And I noticed you chose quantiles and median, and in particular quantiles over, I'm guessing, KL divergence as an option. I'm curious if you could talk a little bit about that. Like what led you to choose quantiles as your sort of workhorse expectation?
A little bit trial and error, actually, in that I think, and actually, obviously, as Niall mentioned, the kind of profile as a starter to be like, here is the types of things that would be useful for your data. As a first pass, we did that, which naturally meant that we had a lot of like maximum and minimum estimates. And I think I shifted from that after a few false positives, particularly on the gross margins around, I think like customers that joined us really early, or specific customers that are on like, you know, mates rates discounts and that kind of thing, which obviously they look quite bad from a lifetime value perspective in terms of like profitability, and that kind of like the absolute value of that sort of like, you know, gets worse over time or gets more extreme over time as they have more and more orders. So I realized, yeah, pretty quickly after starting with the kind of suggested maximum and minimums that something, you know, a little, you know, like this was not the best way to start like, you know, actively doing the distributions. But really, like, I mean, we're relatively, it's been running for a few months now. I don't think we fully stress tested it exactly where it is, but at the moment we're just you know, heavy use of the expectation glossary of expect quantiles to be between, and I usually just choose like 4 or 5, you know, spread out distribution ones. Yeah, I don't know if that's definitely the best option, but it certainly seemed a lot more useful than the, you know, than something which was sensitive to extreme values.
Another thought that you know, I think we're still, I'm just extremely interested like in how people approach the modeling and understanding of their data and like what it means to have an expectation. So there's an interesting duality between the map expectations, or expectations that look at individual records, and those that are looking at aggregate statistics. And so I sort of wonder if another alternative to a max and a min would be a values between paired with a mostly parameter. So you're sort of excluding extreme values, but also being very, 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 very loose about basically the internal distribution of the, I mean, in some ways, these are all just different ways of looking into the kind of expected histogram.
Yeah.
One of the things that you brought up as well that I wanted to just touch on is this notion of expected drift. And I'm really excited to say this is an area where we've been putting a lot of effort right now. And in our new 013 release, a lot of the internal machinery is put in place for making that a very natural thing to express in expectations. So, so as you move into the world of using data connectors and in the new style of data source, it becomes possible to keep metadata about batches so that you can explicitly refer to a lagged batch and a metric from a lagged batch as a part of your expectation parameterization. So we'd love to probably follow up with you and get you on the early beta testing list for making sure that works well for you.
That'd be awesome. Yeah.
As one quick question on that now, as you're using checkpoints now, how are you defining the batches of data in checkpoints?
We are, you know, that is a really good question. I think the way we define each checkpoint has the expectation suites, and then we just have a SQL query in there, which goes to a table. To be honest, I've never quite understood why I have to put the SQL query in the expectation suite and the checkpoint. If someone could explain that, that would be great, because I find it very confusing.
Well, I don't know. I would love to talk to you more about it. Again, the answer is you don't need to, especially in the new data connector world. And I'd love to kind kind of work with you on getting that set up. You know, we've done a lot of work on making sure, again, that these concepts of batches as kind of discrete chunks of data that have a concept of order is exposed all the way through to the checkpoint. So let's do a follow up on that.
Cool. Yeah,
and really look forward to it. Niall, Lorna, thank you so much. It's a pleasure. And let's go ahead and turn now. We've got as our next talk, Micha from Maersk. Micha, over to you.
Yes, thanks, James. Let me just try to share my presentation, and let's see. I hope that it works. Okay, can you see the presentation? Is that okay? Great. So first of all, thanks for having me today. I'm really happy to come in, and I think Niall, it was really great what you talked about at your work at Tails. I think my talk will be a little bit more high level, a little bit more like how do we do that in general? How do we think about it in general? How do we gain value from this in a bigger picture? And it's also a very different setup. So I think it's great that we get some different setups here. So I'm going to talk about basically who we are as a forecasting team. What are we doing at Maersk, roughly at least, and then going to talk about also as you did before, right? Quickly show you how do we do data and machine learning pipelines. We use more or less exclusively Kubernetes for this. And then I'm going to talk about how we implemented Great Expectations. So roughly 3 months ago, we started using it in production and have a good coverage. All our forecasting products are basically using Great Expectations. And then I have like 2 small slides on the pain and gain of the journey. Like you also described, you know, we had the same pains, a slightly different way of dealing with it, I think, but otherwise, yeah, it's very similar. And before I get into all of this, let me just say, like, if you can't listen to all the stuff I'm talking to you about today, take this away. It's easy to implement Great Expectations from my perspective when you use a Python API, as long as you're using Docker and Kubernetes and Git. And that's our main thing. That's how we run. And there's lots of value to be gained. And I hope that I can convince you that it's A, easy, and B, there's a lot of value you can get from doing that work. So the forecasting team at Maersk, and you see Team Avocado, that's our team name. So our Scrum team is called Team Avocado. That's why you will see the avocado popping up. It's not just for fun. This is our name. If you don't know what Maersk is actually the largest ocean container shipping company in the world. We ship between 20 and 25% of the global volume of containers. So it's very, very likely that if you look around you, there will be things that we have shipped across the world for you. We roughly operate 700 vessels, and you know that means if you think about 700 vessels, if you think about a big vessel, a triple E that takes 20,000 containers, so that's a lot of things to move around the world. And you know, doing forecasting on that level means you have to do a lot of forecasts. So our team, what we do demand forecasts. So we don't actually do like financial forecasts, but we do kind of demand forecasts for like shipments and so on, right? And we have a couple of different products. We're a team of like, I can't remember if it's now 10 or 12, but roughly that number. We have software engineers, we have data scientists and data engineers. So we're a team of specialists, and our products are data products. So we don't have to, we're not actually the team building the UIs. We are actually just there to build high performing, high quality forecasts for the business. And then there are other teams who will take care of actually like how that is, you know, put in operations. But we have a big responsibility to actually get, you know, really high quality forecasts, because there are decisions being taken based on our forecast for the future, for like, as you just saw, like, you know, a big part of the global trade. So it's important that it's robust. It's important if we make a forecast, there's good data in, good data out, the same story again, right? So very clear use case for Great Expectations. And when I say we build forecasts, well, the way we do it, we like simple and stupid things. I think that's the best way to put it. We like very simple things because we basically don't do any kind of fancy batch and increments and streaming. We do simple batch running a forecast on the full historical data. So it's rather, you know, it's not big data. It's not huge because we are, you know, talking about physical assets, you know, still. So it's kind of, there's not so much data. The density of data is not that high on any given day. But it still means, you know, we're talking like between like 1 gigabyte to like 200 gigabytes. That's kind of what we're talking about in compressed paquet size. So for us, it's crucial that we build very accurate data that is historically accurate. So it's not just this has been a shipment, but it's like how did the shipment actually evolve over time, so we can see patterns and stuff like this, right? And that means that we have computationally heavy jobs. So we use a lot of resources to actually run our things. And so that also warrants that we have to look into data quality. How we work, in our case, we don't have any users who have to set up their thing. We have a big mono repo, a Git repo, where we have a fully fledged setup where you can come in, and if you're a software engineer, data scientist, or data engineer, it doesn't matter. Everything lives in Git. All our expectations live in Git. You can run locally as you can run on Docker, on Kubernetes. So there's a nice parity. We use DevOps principles, so we have to build, but we also have to operate our forecasts. Yeah, everything is running containers, and it's a very highly collaborative environment. So we really love pair programming. So it's about, like if we're updating expectation because something breaks, it could be a software engineer on support, it could be a data scientist or a data engineer. Everybody has to be able to do that easily, right? There's no kind of calling up the data engineer and saying, hey, you have to fix this, right? If you're on call, you have to be able to fix that. Yes. And as I said earlier, right, we actually, if you're looking at how many time series we put out a day, it's a couple of millions a day actually that we put out, right? And those are important for the operations. So there is a lot of stuff we have to crunch, and yeah, we are a sizable team, but not huge, I would say. Yes. So how do we do this? How do we build our pipelines? Again, we try to do very simple things. So we basically have an in-house operator that is in-house orchestrator. So we're not using Airflow or anything or something that's available out there. We're using a rather simple setup, and we have the way we do it is that you can write a script. I'll show you like a small example in a second. You just write some Python code, which takes some command line arguments, and then you make a configuration that says, okay, whenever this data changes, just run the whole thing. And then, and every job does it. You see it like this is a snapshot from like one of our DAGs. We're not explicitly coding DAGs, but the DAG is kind of coming from having all these configs, right? And then this is a kind of a data provenance mapping that you see on the bottom of the screen. And that's a typical, that's what it takes to run a typical forecast in our team. We have like 3 or 4 of those running every day. So it's kind of nice because we can very clearly separate our code from our data, right? Code and config. And then we basically use Git branching. Let's not talk too much about how we do this, but it's very simple because it allows us to focus on some of these heavy jobs, because a lot of these jobs are actually quite a lot of code because of the way we have to do like model building, of the way we have to do tuning, or all these things. It's all in here, right? There's some data engineering work. There is some machine learning work, and and a lot of reporting work as well for this. We then do another stupid thing, which is a very nice thing for me, is we use, every time we run something, we save an immutable snapshot in blob storage, which means, and because we have data provenance, it means we can go back and forth and see exactly what happened, right? We can really dig down, and if one day we have an incident, and this happens, we have to be able to say, okay, what is actually the data set that changed, right? To say, where does the error actually come from? And you can guess that it's getting quite complicated, right? Once you're in the kind of a 16-layer DAG, as you know. So it's a very simple setup that we use. It's just you write some Python code as shown here, right? You can merge, for example, 2 data sets, and you make a config. Like, they are very, very simple. Our configs, you just say, well, what is my source? What is my destination? And then we have a very simple thing that's called GE entry point. That's a wrapper that I wrote. That basically then it resolves the data set name for everything, and it just runs the expectation. We'll get to that in a couple of slides how that works. But it's very different from using checkpoints. We're using the Python API to basically wrap around our orchestrator, or not the orchestrator, but around the system arguments. It will just say, okay, this is the data set name. I'll pair to this expectation, because we use a simple convention of naming them the same thing. And then it just runs it, right? It means you can run input checks, output checks, without any additional work in the pipeline code. You're not actually having to write anything. It's just, once there's a JSON file in your expectation, and the data source has to be configured as a kind of fake entry, so to speak, because we're not using it for more than that. it will just run it, right? And you don't have to worry about anything. We try to also follow functional data engineering practices. Maybe let's skip this slide, but basically exactly how our stuff works. Think about it like this. We have an awesome pipeline that runs. We have a trigger. Mostly, as I said, it's when upstream data changes, it will run. It will then see, okay, what's my code? What's my sources? It will save those things. So you know, okay, I use this exact git commit, actually. So it saves the SHA code. So we know exactly what code it ran with. We know exactly what data it ran with, right? So we have like this completely traceable system to be able to debug when things go wrong, like they do every day, right? So we spend a lot of time there. And so just, you know, to bring that home, it's kind of, if we have like different sets, bookings and commitments or contracts, we have a trigger that anytime something updates, you know, it runs the job, then we make a forecast, and then we save, you know, timestamped and code. And so we know exactly how, what when we can make it, we can rerun the thing. That's kind of important for us because we're kind of, as I said, you know, there are things relying on us in the operations. So we have to be able to always go back and make sure we're improving next time we run a forecast. And so how do we implement Great Expectations? When I joined the team in March, they already had some of these things in production, but there was no real data quality checks except from the typical, like, oh, you know, assert something if the data freshness is some value. So you do some kind of checking of specific columns, you write some code, but like no systematic like data checking and no systematic documentation. And I think you guys also mentioned in the talk before me is like, what happens if a person leaves, right? If like all this intimate knowledge you have of all these data sets, right? That kind of leaves the team. And that's really bad for us because we have, as you can imagine, we're a 100-year-old company. We have a lot of different systems. We have to integrate from a lot of different parts of the business. You know, you have to really be at the company for some time to understand all these old systems and how they run and how you have to build these, how you have to build the data sets and what you expect from those data sets. It's kind of also for us, not just validating data, but also kind of having some record of what do we expect from the data, what is normal and what is not normal. So the way we run expectations, and sorry that this slide looks a bit messed up, but it's very, very simple, I think, the way we implemented that, because we just run, like, as I said, on Kubernetes. So you can just run your expectation exactly like you run it locally, because if you set up your context in Docker, right, it's like as if you have, you know, when you do Great Expectations in it, you get the Great Expectation folder with all the stuff. And so we use a default setup, so it will just pick up the data context as it is, exactly like you see it in Git, exactly like you work in your development environment locally, and then just picks it up there. There's no work you have to do to fiddle around with deployment or make another YAML. It's basically the same thing. You can run it locally, and you can run it, when you deploy to Kubernetes. It will run the same, right? And then for each of our products, right, we have our own setup. So every product has a Great Expectation folder with the JSON files in it. That's how it is. Then we have the base Docker image that, you know, constitutes the job, and then basically with the entry point patching to run the job, you know, it has a context in it. It will just run it. And I think I can actually also show. Okay, just to finish this slide, when we alert. So I think you guys from Tails, you showed a really nice strategy of how you alert. We in our case, we don't actually use alerting from Great Expectations directly, because we have alerting in prod set up using Datadog and PagerDuty anyways. And then we are kind of having some pretty logging that we put into the log. So every time there is an alert in PagerDuty, you see if it's actually a validation, you see exactly the failed expectation. It will tell you, like, and that's actually a nice feature from Great Expectations you should use, is like you get this observability of what was actually wrong, what kind of data is in there. So you don't have to go and maybe go through 20 gigabytes and figure out what was wrong, but you can actually know, okay, it's actually because, okay, this string wasn't, you know, I shouldn't have this kind of transport mode in here, or I shouldn't have this and that, right? You see it immediately. So you can go in, dig in and start debugging right away. So yeah, we don't use this kind of setup that comes with Great Expectations, but it kind of, there was again no work because we had the alerting setup and we just put it into the log. So it just came for free for us. And then on the bottom, you can see just a condensed version of this config, right? So the only thing this entry point actually does is it looks at, okay, there's a data set called orders. Now the system argument should give me something about orders in the source one, and then it gives me a path of where the data is downloaded to in the Docker file, in the container, and then it just runs it over that, right? That's all you have to do. And you don't have to think about that, right? You can just say, okay, I have an expectation suit here in my expectation folder. The GE entry point will just pick it up and run it against the data set name. You have to only follow this convention. Again, we like simple and stupid things, so that was good enough for us. And if you're interested in how that works, because again, we're not using the checkpoint, it looks like something like this. If you're interested, I can talk you through it maybe after talk. It looks a bit messed up on the slide right now, but it's extremely simple to just, you just take a system argument, resolve it to the data set name, and then you run it. And we can break it for input, but we can also break it for output, right? And that's the output thing is also like a key feature for us, it turned out. Yes. So how do we use that? It's kind of we use it, I would say decoupled, but in line. So it's kind of, it runs. You can see this. If you take this diagram from the left, we have some source data, and there could be multiple source data. It would just run all the checks. And if it breaks, it will break the pipeline. It will trigger our pager duty. It will say, okay, this is what breaks. Go fix it, right? And then you can fix it, and then the pod will it will respawn the job, right? So it kind of, as soon as your commit is through, when if it's just an expectation you have to update, right? Then it's very easy fix. If it's not an expectation you have to update, you might gonna spend a couple of days on debugging, or not maybe a couple of days, but you can spend a kind of infinite amount of time debugging this. And once the sources have been checked and it's okay, you then run the job, and then you check the destination data again, and then it goes exactly back to what Lorna was saying. Is kind of, then you have to really make sure, okay, what are actually good ways of checking the distribution of the forecast? What is actually good? How does a good forecast actually look like? When we started, we didn't know it necessarily, because you can imagine we have a lot of data. And if you haven't looked at the distribution, if you haven't looked at the quantiles, but you've only looked at maybe a certain kind of your certain spectrum of what you typically look at, what users have pointed out or whatever, it can get really hard to actually start figuring out how to write good expectations for that data. So that's really the pain that we felt. Yes, but again, like with this setup, it allows us to basically run input and output, breaks on failure to validate. And this feature of checking the output, or you see the other thing that we have a system where if we break on output, our orchestrator will actually take the data set. If there is a data set, it will take it and put it into a failed state. So you can also debug that. So you still have the output, and you can then dig into what is wrong with the output, because otherwise you would have to kind of go into the process, run the thing, and then kind of create it. But in this way, it will still keep the output, but it won't be published. So we have a kind of way of defining what gets to a destination like that is, we call it batch, which would be things that get published, and then failed, which is kind of if the pipeline failed but still produces data, we'll keep that for debugging, right? So you can always go in and check. And that has worked pretty well as well. And then a nifty little tool, I could only encourage you to do that if you're like us and you have a lot of products already running, and you need to kind of, your PO tells you after the last incident, now we need great expectations, you need to cover all your data. Maybe write something like we did. We have a small GE coverage script that basically crawls through our prod config, compares it to all the expectation suits we have, and tells us that we have good coverage or not, right? So if your awesome forecast for real this time data set actually is covered or not, that might be really important for you. So kind of, it's like it's like a very rough version of a unit test coverage thing, where you can say, okay, how much of this big product of this pipeline have I actually covered? Because you can lose the overview. You saw the DAG. It's a lot, right? To figure out what you have and where you have it, it can get pretty messy. And again, it was a super nice thing, super easy thing to do. I'm also happy to share that code if anybody's interested in that. Pain and gain, I think I covered most of that already. And of course, I can't tell you like all the details of the actual incidents, right? What we experienced, but like I can tell you that things break all the time, right? We have, as I said, we have a kind of a big legacy landscape of things. We have multiple data warehouses. data lakes, data platforms where we kind of gather data from, which means things break, right? You will hit race conditions, and that's something that we actually experience in some systems when you're copying over your data or when you're accessing data. So yeah, things break. And in the beginning, and maybe Lorna, you can you have the same, let's say, made the same experience. A lot of things when we started, we broke our data pipelines, but it was just because we were really bad at writing expectations. We actually built a custom profiler, which actually also looks at column names to kind of give some reasonable suggestions for people of how to build an expectation suite. So, you know, when you run a profile, we have some kind of helper script that run profiling more or less automatically and then suggest some reasonable things that we have learned over the time that are good for us. And that's, yeah, that was really, really painful trying to learn like what is actually good and what's actually bad. That took us quite some time, I would say. A lot of frustrated people on support for a couple of weeks, but once that subsided, we actually started seeing things that broke, and then we realized that it was actually because we had real issues. And so, as I said in the beginning, our forecasts are used to make operational decisions every day, which means if we are breaking a forecast, you can imagine what kind of impact that can have in the real world if there are decisions, commercial decisions being made on an operational daily basis based on that forecast. So I can tell you that we have like at least now a handful of incidents we had before that we don't have. So we see a breakage and we see, okay, it's actually the same like symptoms that we saw back then. It's something we cannot fix on our side because we're meeting we're hitting a race condition in this case. But now it's prevented, now it's stopped, right? So we don't actually output anything anymore. We don't publish a forecast. We kind of wait until we can either fix it ourselves or until it gets fixed automatically with the next run, right? But it's really, really valuable for us to have that. And it's also, I think Niall put it in the beginning, it's like, you know, you can sleep at night because you know, okay, now this breaks, but it kind of keeps you from, you know, making some, you know, putting out something bad that will cost us a lot of money. And that's a really good feeling, right? And it's also good for your PO to see, look, we had this thing in the past, like half a year ago, we had this issue, and now it happened again, but now we actually didn't, you know, there was no, the business didn't know. And that's where you want to be as a kind of engineer, right? Or system, like a SRE or whatever you are, right? You want to be in the position where nobody notices you're there. That's kind of a good feeling, I would say. So yeah, we prevent a lot of stuff. We also actually realized a lot of things about our data. So when we went through that process of, okay, we have this list of all this data, intermediate sets and the models and the features and all these things, we realized, hey, there are some things that don't make sense, right? You have some columns where you haven't thought about it, but then you have some nulls there that shouldn't be there, or like some empty strings that you suddenly realize from the profiling. And we have a list of things in our backlog now just to kind of go through these small things that we found. And it's very small amounts of data, but you never know what that kind of does downstream, right? So it's kind of that visibility is also really, really crucial for us. And it has like, we have learned a lot from that process, right? So the pain, you know, really, really gave us a lot in return, which was good. And then lastly, I think I wanted to just say a couple of words that like what this has done for us is that we have a team that collaborates on the data quality, like we do with all the other things, right? So it's just part of our kind of constant improvement as a team, which is great. Because when I did the POC, you know, you're not sure like, okay, it's a new tool. Is it something that we will take on further? Is it sustainable to keep that? And after 3 months, it looks like, yes, it is. And like, it's not me who is driving that, it's kind of the whole team is driving that. Also, we have made quite some use of the extensibility of Great Expectations. So for example, the notebook templating, I think that was actually my first PR to Great Expectations to change the gender templating, because as you might have seen, we're not using a single database, right? In our internal things, it's all just Parquet files and, you know, some branching and blah, blah, blah. It's actually super cool, but the point is, you know, we're not, that means, you know, how do you get your data if you want to get prod data? We have an API and a CLI, which we just templated into our notebooks. So a user can just, you know, say, edit expectation suite, and it will pop up and it will automatically populate the right CLI command. So then that will download the data for you, or it will put it somewhere where you can read it directly without you having to think about, okay, I have to go there and download a file. It's all handled, right? We have some way of abstracting that by ourselves. And it was super easy to put that into the Jinder template once we made the PR to kind of allow that more easily. And the other thing we have done very recently, so I haven't anything to share for that, but we have used the data documentation or especially the expectations. Every time you make a commit to master in our setup, in our Git setup, it will look through the expectation, it will render them as markdown and then put them into the MK docs. So now like all our technical documentation lives in a kind of MK docs. So we have like our nice documentation there. And now every product has its data sets, organized by expectation suits and kind of rendered. So you can see when a kind of the whole, like a documentation and an automatic documentation that is not, somewhere where you have to put it with a YAML, but we actually put it directly into the MK docs. So it's directly inside the documentation. It's not a link to where we store it. So it's again, you don't have to put that into YAML and to put it somewhere remote. You can also do that actually as part of your CI and have that rendered in your MK docs, which is also super nice, I think. So yes, but that's me. Thanks for listening.
Micha, thank you so much. Man, again, just all the use cases are so fun for me to hear. Let me open it up for questions. Any questions?
In Maersk, when you talk about containers, are you sometimes getting confused which ones?
Of course, but we love containers, so it's okay, I guess. So yeah, we do get confused. Yes.
I will say one of the things that I found really fascinating in your talk is the specific focus on being able to tell why there was something going on, as well as your comments about the use of the profilers for being able to basically fill a backlog of issues. Frankly, that's not something I've ever really thought of before, but this notion that, even after discovering issues that may not rise to the level of priority that you want to actually tackle them right now, but you can still be surfacing those issues for subsequent evaluation. That's a really neat use case.
It also came as a surprise to us, right? So we didn't know, and because things were in production, you're not kind of building greenfield all the time, but if you want to implement that into a running thing, and then you start looking, you will find some things that are wrong. And we've actually made use of this commentary notes feature. So when we were going through that and running the notebooks, we used this markdown node, so we can easily render it, and it gets rendered automatically, right? So you have all these expectations every time we find something that is like, oh, this is odd, there's an empty string instead of a null or something, we just type in a comment. So we have that already set up in the documentation that we don't have to, again, we really like simple things and automated things. We don't like to have things in two places. So that was perfect for us. Yeah.
And in particular, that's the meta notes section that you're using?
Yes, it's the meta notes section. Yes.
That's great to hear. One of the things that we're also working on, in fact, that I'm working on right now, is improving the way that our profilers work. We've done, yes. And you mentioned extensibility. We've done a lot of work in this most recent release to make Great Expectations even more extensible and modular. And that's kind of trickling down rather now into profiling, where profilers can be able to take advantage of metrics in a much more atomic way. So I'd love to, I guess I just love getting to be educated by everyone who's got great ideas and also push forward what we're doing.
I think that's great. I think that there were actually some things we stumbled upon which were a little bit odd when we used, but it was like an older version, right? That was about that it kind of added expectations that we didn't want, right? And you had to go to the parent class to turn off like getting like some of the expectations in. So yeah, that's very much appreciated. We haven't looked at 0.13 so far, to be honest. But it's something that is, I think in January, February, we'll tackle some more of the observability of our pipelines, and that's part of what we'll upgrade and also see what we can improve in our setup.
Excellent. All right. Well, Micha, thank you again so much for your presentation. And now we've got one more presentation for the show and tell today. Pete and Kenton to talk about their work at Astronomer and integration with Airflow. Over to you.
Yeah, thanks, James. This has been a lot of fun. So thank you all for coming on. And it's been a lot of fun to see kind of great expectations, use cases in the wild. You know, we have learned a lot about great expectations in the last couple months from working closely with the team on the Airflow provider that we've published in the last month or so. But obviously, like, don't get the day-to-day exposure around actual use cases. We more see it in the context of Airflow over here. So such a pleasure to be able to hear you all present. I'm going to walk through a couple of quick slides just to kind of contextualize where we're going with this new Great Expectations integration that we've published with Airflow. And I have Kenton, who works with me at Astronomer, to walk through a full demo of the operator itself and how it's used in a specific kind of Airflow context. So for starters, let's talk a little bit about Airflow. I know I don't really need to go too far in here because most people on this call are probably somewhat familiar with Airflow, at least at a high level. Airflow is a data orchestration tool, workflow orchestration tool. It was born inside of Airbnb in 2015, open sourced. At this point, it's the most popular open source tool on the market for data orchestration. It has about 19,500 stars on GitHub, I think. 600,000 downloads from PyPy monthly. And, you know, we are the company kind of driving Airflow development forward, and you know, Astronomer is the Airflow company. And, you know, we really work closely with the community and with a lot of other tools in the ecosystem on building out good integrations around the Airflow layer itself. A little bit about us, just if you're not familiar with who we are. We build products and services around Airflow, namely, you know, managed Airflow service, or enterprise Airflow platform as well. That basically just allows you to easily provision, manage, run, and operate Airflow environments at scale. So, you know, we usually meet people at some point in their Airflow journey, help them, you know, kind of level up their Airflow game to whatever the next step is, whether that's just getting started, you know, wanting to run their data pipelines without worrying about any infrastructure, or wanting to scale the, you know, a true enterprise grade data platform. Forgive me, I pulled this from one of our sales decks. I know it's a little bit salesy, so I won't go too far in here. So yeah, I mean, this is very rudimentary, so take it with a grain of salt. But at a high level, you know, one of the things that we're really committing to is digging deeper into the ecosystem of tools that are embedded in the modern data stack. So things like Great Expectations are kind of front and center there, right? We see tons of Airflow use cases every day. You know, it's such a flexible orchestration layer and lends so much optionality that there are so many different things you can do with it. So we've actually seen it used for many, many things beyond, obviously, the ETL, ELT paradigms and machine learning paradigms. But as we started to kind of dig into the validation use case at the request of some of our customers, a common pattern we saw was Great Expectations. You know, we had a lot of customers that would reach out to us and say, hey, how do you all recommend we use Great Expectations in the context of our DAGs? We're not really sure how to do it. A lot of them had maybe written their own, you know, Great Expectations operators, like the folks at Tails did, that kind of wraps the Kubernetes pod operator. A lot of people were just invoking Great Expectations command with the bash operator or Python operator. So there wasn't really any standard design pattern around how to actually run these validation tests in the context of your DAGs. Obviously, I don't need to go too deeply into why this is important, right? I know Micha touched on this as well. You don't really want to run your upstream tasks if the data that you're running those upstream tasks on top of is no good. That can be very expensive if you're spinning up a lot of compute. It also can affect production user-facing applications if you're serving models to be consumed by anything you're running in production, and you know, the data has not met a certain criteria. It's a very important use case in the context of the end-to-end data lifecycle, right? You really don't want to do those expensive, kind of costly production outage risk things. And Great Expectations helps you prevent that in the context of Airflow. So a lot of these conversations kind of happened in tandem with the Airflow 2.0 release. I don't know how familiar anybody here is with Airflow 2.0. It actually is coming out on Thursday of this week. We're really excited about it here at Astronomer. It has been a ton of work from the community, and it's been kind of a superhuman effort over the last year. a couple of the new features. There's a highly available horizontally scalable scheduler now, so you can run multiple schedulers. It's no longer a single point of failure. We have a production API that you can leverage. We have a big UI refresh, and then there are many other features as well. But the one I really want to talk about is the new providers framework that's shipping as part of Airflow 2.0, because that's really what is interesting from an integration perspective. Historically, Airflow integrations called hooks, operators, sensors were included in the core Airflow release. So they were included in the underlying Airflow code base. So what users would do to access those integration points would be just import them from Airflow directly in their DAG files. So you write your Python file, you'd import an operator from the underlying Airflow code base and execute that within the context of your DAG. What's happening post Airflow 2.0 is that core Airflow provider packages that contain all of these submodules for integration have been decoupled from the core Airflow code base and released and versioned independently and distributed on PyPy as their own Python packages. So what that enables users to do is just import packages that they need for integration directly from PyPy. And it enables us as maintainers and as users to independently version and improve and maintain those packages. So you no longer need to go through the process of shipping an Airflow PR to this massive repo with all of these, prerequisites and, this very strict review process just to make a change that affects the integration layer between the Airflow operator and whatever third-party API we're interfacing with. Now you can run these as their own kind of software projects. We like to think of it as plugin freedom. So this is all just to say this new providers framework was kind of coming to fruition in tandem with us exploring these great expectations integrations with our customers. So we figured it'd be a great opportunity for us to actually build a new official great expectations provider package independently of Airflow in tandem with the superconductive team. So that's what we went ahead and did. It's available on GitHub. I can link anybody to it if you're interested in exploring. We have some guides on it as well. But basically what it is its own Python package that users can import into their DAG files. And then they can execute our official great expectations operator directly in the context of their DAG. We also are encouraging users to make PRs if they would like to extend that base operator that we've built, or build any other interaction layers between great expectations and some data store. So, this is really the future of the way integrations are going to work in the context of Airflow. And we're really, really excited to show this off. So I want to throw it over to Kenton, who's a field engineer on my team, who has built demos for customers and kind of shown off this provider in a couple of different contexts. And she's going to walk through a quick demo of what it looks like in action.
Awesome. Thanks, Pete. Go ahead and share here. Okay, so like Pete said, want to just show an example that we've put together on how you can integrate great expectations into the context of your DAG. And I'm going to do that within the context of using an astronomer project. So sort of thinking through, if I had a DAG that I wanted to make this integration with, how would I sort of look at that locally, test it, and then deploy it to an astronomer project. So I'll start by just getting Airflow up and running locally. I have this code editor navigated to a directory where I have my great expectations files and some example DAGs. So I'll highlight briefly the astronomer CLI. We provide this as a way to interact with and manage your astronomer projects, but it's also the easiest way to get Airflow up and running locally. And it is available open source, so anybody can download this and do what I'm about to do here. So to get Airflow up and running, I can just initialize an astronomer project using astrodev init. And that's just going to set up all of the necessary files and folder structure to run Airflow in a Dockerized setting locally. So what you're seeing here is essentially our opinion on best practice for using Airflow with Docker. And then to start up locally, I can do astrodev init and astrodev start. And that's going to spin up all of those Docker containers to get me up and running locally. So you can see, just like that, I have an Airflow web server up on my local host 8080. I'll pop over there in a minute, but before I do, I want to, again, sort of highlight this file structure. And in this code editor here on the right, I have this open to the same directory you saw me working in over here. Things I want to highlight. So I have my DAGs folder, which if you're familiar with Airflow, you know this is where all of your DAGs would go. And we'll walk through that one in a moment. I also want to highlight this include directory. So this is where we would recommend putting any files that your DAGs need to access. So this could be anything from, you know, external scripts or like operators that you're calling to all of the Great Expectations framework. So my data, my Great Expectations checkpoints, the expectations themselves, etc. I can put all of this in here, and then it's going to automatically get bundled up with my Airflow project. So if I navigate over here now, go to my local host, you can see I have Airflow up and running locally. And so I'll talk through this example ADF Great Expectations DAG that you see here. And I'll just start with a graph view since I think it's easier to sort of visualize before we jump into the code. But what this DAG is doing is essentially it's running an Azure Data Factory pipeline that grabs data from a COVID endpoint and then saves it to Azure Blob storage. You could do this in many different ways. We have this particular example set up just to show that Airflow integrates really well with many other tools. So while you could create a pipeline directly in Airflow that would do something like this, you could also, if you already have pipelines in a tool like Azure Data Factory, there's no need to like convert them. You can have Airflow orchestrate them from here. So that's what this first task is doing, is just triggering that remote pipeline. The download data is to bring the files that it's storing into blob storage locally so that we can run a Great Expectations check on them. And so that's this task here. After that, we have a send email task just to highlight that you might put a Great Expectations check in the middle. So we've already seen a lot of examples like this where you might have some downstream dependency that you don't want to happen if your expectation fails. So I will pop back over to my code editor and walk through this in a little more detail. So again, I have this expectations DAG here. This a little bigger. As Pete mentioned, we have the Great Expectations operator. So that's imported here as a provider package. Can also import the other packages that are needed to go along with this. So data context, data source configs, etc. All of my other imports here are related to the other tasks, so the Azure Data Factory and pulling that data locally. So again, lots of hooks and operators available out of the box that make this whole thing happen and not very much code. From there, we just define the Great Expectations file path that it's going to reference. So again, in this case, I'm pulling this data locally, and I also have all of my Great Expectations supporting files in this include directory. So this is just going to tell Airflow where to look for that. And then setting up the data source config, or the data context config, excuse me. So again, just telling Great Expectations, this is what the operator is going to use so that it knows where to look for the data and what expectations to use. I have a couple Python operators that, again, make use of those hooks that I was talking about that just run the Azure Data Factory pipeline and then grab the blob files and pull them locally. And then down here in my DAG definition, you'll see the 4 tasks that I was talking about in the graph view earlier. So again, 2 of those Python operators, and then currently here, I have the Great Expectations operator. So again, I just pass in the expectation suite name, the checkpoint name, and then that data context that I defined above. And then from there, I can set any downstream tasks as I want. If I go back here and again, just point out that those things that are referenced are here. So here are my checkpoints in this include directory and my expectations. Expectation file in this case is very straightforward. I just have a couple sort of as an example. And in this particular case, I have set this up so that I know this expectation is going to fail, just to show sort of how that propagates through to Airflow. So if I pop back over here and go ahead and turn this on, and that's going to start this running. I'll pop back over here. It'll take a few seconds to go through this. But when it's done, we should see this task fail in any, oh, sorry. Not sure about that one, but what you should see is these two tasks succeed and then this one fail. I think the connection was not set up correctly, but in any case, if I said I was happy with this example and I wanted to go ahead and deploy this to a Plate Astronomer project, I have one up here. So this is the control plane for an astronomer project. So you can see I can go ahead and open Airflow from one of these, and this is my deployed Airflow instance. If I want to push this DAG up that we were looking at so that it's in this example, I can go back to my terminal and I can do all of that from the CLI. So first I will authenticate to this workspace. I'm doing Astro Auth login in my workspace, and it's going to prompt me for this token. Okay, so now that I was successfully authenticated to the workspace, I can do Astro deploy. And I'm going to choose the workspace I want to deploy to. And then it's going to go ahead and bundle all of that up, and it successfully pushed that to the astronomer registry. So that will be now this DAG and all of the associated materials with it will be available in my astronomer workspace.
Obviously, it goes without saying, but this is accomplishable in any Airflow context, not just an astronomer environment, an astronomer Airflow environment. So we have guides that I can drop in the chat on how to do it both ways, as long as this data context is available to your DAGs. It should be configurable.
Yeah, that's a great point. I will say there's, yeah, like Pete said, lots of ways that you could set this up, and that the operator is really flexible. Again, in this particular case, we're pulling the files locally and running the expectation from there. You could also, part of why we did that in this case was because these files are on Azure, but you know, in the future, you could probably run the expectation directly against those files. And if you have files in some other sort of cloud storage, you could do those directly there as well. And that's all possible using this operator.
Yeah, one of the things we're really excited about as well, I know I mentioned it briefly earlier, but I just want to kind of reinforce it. One of the great things about the Airflow operator framework at large is that it's super flexible and kind of community driven. So in most contexts, like the interaction layer between Airflow and any tool, there exists many different operators that cover different use cases and remove boilerplate for certain kind of interaction layers and user stories. So we're really excited to extend upon kind of this base Great Expectations operator to kind of cover a broader surface area of use cases.
Yeah, thanks, Pete.
Thank you. Thank you both. I have to ask, I mean, there's so many, so much convenience, I think, that this showcases. And one of the things that I'm really interested in and that I've seen a lot of people talk about is like where they run expectations and checks. And I think, you know, you put in your example, Pete, at the very beginning, a couple of different locations for running validation in a typical pipeline. As you have been out and talking with different people who are deploying Great Expectations, have you noticed a pattern there, and or a pattern with respect to the use of expectations to you know, halt pipeline running versus being exclusively parallel as a way to produce an additional signal?
Yeah, so most of the cases I've seen, it's been used as a mechanism to halt upstream tasks. Specifically, I've worked mostly in the context of kind of the ELT paradigm, right? Like, we see mostly like ETL, PLT, LTLT, or whatever. So there are many different places where you can kind of sprinkle in validation checks and it's appropriate. Candidly, like, we're really looking to explore this in more depth with our customers, because a lot of the initial conversations we had were with people that proactively reached out to us to discuss this, and indicated that they would like kind of a blessed way to build these checks into their DAGs. But looking forward to kind of exploring additional use cases as well. I think the parallel use case is interesting. And also, like, for context, once we published this guide and this blog post and the operator and stuff, a bunch of our other customers reached out and said, hey, like, we want to set up time to figure out how to use this thing. So I'll keep you updated.
That's great to hear. Absolutely. One of the things that we're really pushing again, and I think I probably sound like a broken record here in terms of my level of excitement for how the Great Expectations framework is evolving for making it easier to access different data sets, is the you know, this data context and data connector API changes. And one of the things that we are doing as a part of that is really making the configuration of the checkpoint much more intuitive in terms of understanding, again, the sequence of an order to different batches. So I'm really excited to see how the more flexibly defined checkpoints can interact with the operator and how people deploy them in that way.
Sure.
Are there other questions for Peter or Kenton? Gonna make it easy for me. I get to ask all the questions. So one of the other questions I've had, and it is kind of maybe about around like typical DAG complexity. We have by the way, we have a dog here. I don't know if you heard the bark there, but we have in one of the original articles that Abe and I wrote when we were first working on Great Expectations a couple of years ago, we talked about this notion of DAG complexity growth. Micah, I noticed in your graph of the Maersk pipelines that this really interesting relationship between the snapshotting, it sounds like, of every single node, which I find really, really cool, and also integrates very closely with some of the thinking that we've been putting into batches, as well as a significant ability for there to be parallel dependencies or cross dependencies. How, I guess maybe this is just an anecdotal question to start off with, but how complex is the typical Airflow DAG for an astronomer customer? Like, are we talking what, you know, and when I say how complex, I mean, like, to what extent are these DAGs relatively linear versus what I would call thick?
Yeah, I mean, I would say I don't know that there's a typical answer, and that's part of what's so great about Airflow is that there are cases where you might have a DAG, you know, I've seen DAGs with a single task or like 2 or 3 sort of independent tasks that are getting run. I've also seen DAGs with hundreds of tasks that have very complex dependencies and sort of everything in between. So I don't know that there's a typical answer, nor is there really a right answer. And that's, again, part of what I think makes Airflow so great is that it kind of handles that huge scale of potential possibilities really elegantly.
Makes me want to throw some expectations about degree distribution of nodes in Airflow DAGs.
We welcome it. Yeah, it's funny. We were working with somebody recently who was considering just using Airflow to run single tasks that ran the Great Expectations operator on top of data sets with nothing else going on in Airflow. Everything else was happening elsewhere, which was a use case that I hadn't seen prior, but it was a good tool for the job in that case too. So,
awesome. Everyone, thank you so much for coming to this show and tell, and special thanks, of course, to Niall and Lorna, to Micha, and to Pete and Kenton for their presentations. Having a community of people that's using Great Expectations makes it so much fun for me to get to work on it. And I know for other people, one thing that I would love to see is everyone in this room getting a mug just as cool as Niall. So we would love to help support you in contributions, great and small. If there's a great feature that you have developed or one that you really want, please reach out in Slack. And Eugene is kind of like all over our public Slack, and Kyle's in there all the time. And both of them would love to engage with you and direct you to somebody who can help work more closely with you on that kind of a contribution if you'd like to. Again, thank you so much. Kyle will get this posted up on YouTube in the next little bit. Are there any more admin things we need to flag to close it out, Kyle?
No, that's pretty much it. I'll make sure to get the video out to everyone. Also, I've been taking people's questions from Zoom and putting them in the Slack just so they can stay, since Zoom chat gets lost. So make sure to check into that Slack channel for any questions. If you have any more questions that pop up later, feel free to ask them in there and tag whoever you want to answer.
And one more thing, if you heard interesting quotes, like any thoughts about other people's presentations, actually post them in Slack. Like, I'm sure it will kind of spark a conversation, and other people that are not here would love to see that. Like, it was really amazing. Thank you.
Absolutely. Thank you all so much.
Great. Thanks.
Thanks, everyone.
Thanks, guys.
Thanks, everyone.
Thank you.